Okay, so in this question we've been told that there's a curve and its gradient has this formula here. So dA dt equals 60 minus 3at squared. We're told that it's got a maximum turning point when t equals 2 and that it passes through the point 162. And we've got to figure out the equation of the curve. So the answer we're looking for is going to be of the format, the function is called a, so it's going to be a equals something. So we can take a few guesses. So we know that it's got a square in the gradient, so it's probably going to have some cubes in there, maybe some number in front of there, and so on. So it's going to be a formula, something like that. Okay, so how do we find out the equation of the curve? Well, the first thing I like to do is draw a little bit of a sketch. Now, it's not going to be an accurate sketch, and this is not something that I'm going to get assessed on, but let's say the curve looks something like this. Okay, I have no real idea, except I know it's going to be some sort of cubic. And I know that at t equals 2, it's got a turning point, and it's a maximum. So let's say that's 2, and it's the maximum here. Okay, the maximum turning point is when the gradient equals 0, so we're going to be able to make use of that. It also passes through the point 162, so that's 162. So I've got this curve kind of completely wrong. It probably looks more like, I don't know, something like that. But that doesn't matter, because all I'm doing here is trying to get some idea, some visual representation of what it might look like. We're not going to use this graph to get the answer. It's just to give myself a picture of what it looks like. Okay, so how do we find out the equation of the curve? Well, we know the gradient is this formula here, dA dt equals 60 minus 3at squared, and we know that it's got a turning point at t equals 2, which means that the gradient is 0 when t equals 2, because that's what turning point is, it's flat. So 60 minus 3a times 2 squared. So 2 squared is 4, 4 times 3 is 12, so 0 equals 60, take 12a, bring the 12a to this side, 12a equals 60, a equals 5. Okay, so now we know what a is. It doesn't give us the answer to the equation of the curve, but at least we know a. Okay, so what's the next step? Well, the next step is that we know the other piece of information we've been given is that it passes through the point 162. So let's look at what we've got here for the function. So far we've got the gradient function is 60 minus, so 3 times 5 is 15 t squared. So that must mean if we do the antiderivative of that, or the integral, we're going to end up with 60t. T squared, the antiderivative of that is 1/3 t cubed. So times 1/3 t cubed plus our constant. Okay, so let's just simplify that as much as we can. 60t minus, that cancels, 5t cubed plus the constant. And now we can use the fact that it passes through this point 1 and 62. So we know that 62 is 60 times 1 minus 5 times 1 cubed plus a constant. So what do we get? 62 equals 60 minus 5 plus c. That's 55 plus c. Subtract 55 from both sides. We get 7 equals c. c equals 7. Okay, so the answer is, the equation of the curve is a equals, let's substitute back into this equation here, 60t minus 5t cubed plus 7.